Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the XXE injection module titled Exploiting Blind XXE to Retrieve Data via Error Messages. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on XXE injection labs, and then go to lab number 6 titled Exploiting Blind XXE to Retrieve Data via Error Messages. All right, let's get started. This lab has a check stock feature that parses XML input but does not display the result. To solve the lab, use an external DTD to trigger an error message that displays the contents of the XXE passwd file. The lab contains a link to an exploit server on a different domain where you can host your malicious DTD. Alright, so the target goal of our exercise is to exploit a blind XXE injection in order to display the content of the XXE passwd file. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Okay, the first thing we're going to do is look for a parameter in the application that accepts XML input. So click on View Details and then click on Check Stock and send that request to Repeater. Now in Repeater, you could see it's supposed to request to the /product/stock endpoint. And if you go down, it's taking in XML input as a parameter to the request. And so this definitely should be tested for XXE injection. So if we hit send right over here, you could see it displays the number of stock that is left over for product ID 1 and store ID number 1. Okay, so as usual, the first thing we're going to do is test it using a general or a regular entity. So let's write that right over here. So regular entity. And the way to do that is create a document type definition. So doc type. This could be called anything. And then define our external entity. So entity, again, this could be called anything. System. And what this does is it will essentially ping our attacker controlled server. And for that, we're going to use Burp Collaborator. So one note over here is that you don't need the professional version of Burp to complete this exercise. I'm just going to use the collaborator functionality to see if I get a ping back. And if I do, we're going to complete the rest of the exercise using the server that is provided for us in the Web Security Academy. Of course, if you're solving this and you don't have the professional version, you could just right away try and ping your regular server instead of using Burp Collaborator. But it's really useful to understand how Burp Collaborator works. So I'm going to click on Burp and then Burp Collaborator Client and then copy to clipboard and put it right over here and go back to Burp. Now this defines my general entity. So we'll add that right before the root of the XML script, hit send. And you could see over here, I don't get any errors, which is all good. Next, what we need to do is reference our entity. So the way to do that is using the ampersand sign, XXE, and then the semicolon and hit send. Now you could see over here, it gave me a custom error saying entities are not allowed for security reasons. So when we did reference the external entity over here, we got an error. However, when this was just product ID, let's say 1, and we hit send over here, we didn't get that custom error that we just got, that external entities are not allowed. And so my guess is that it's making a check over here to see if there's any references to external entities, and if there are, then it blocks the request. So what we're going to do over here is instead of using a regular entity, we're going to use a parameter entity, which we've used in previous labs. So again, it's really similar to a regular entity, except it can only be referenced in the DTD itself, and it has a few syntactical differences. So over here, it's a % sign, and when you reference it over here, again, you reference it with a % sign, not with an ampersand sign. So we've got XXE, and semicolon. Let's copy that and put it in here. Hit send. And this is interesting. So you could see over here, it says XML parser exited with an error. So the root element type must appear after doc type. So this is really interesting. First of all, this outputs the error of the XML parser. And so I could use that to my advantage in order to exfiltrate data from the system. What we're going to do is we're going to go back to Burp Collaborator and click on Poll Now to see if it did send a request to my Collaborator client. And it didn't, which means that there must be an error in my exploit. And I know what the error is over here. This should be HTTP. I believe this should be the error, but we might have something else. So hit send. And we still get the same error. Click on Poll Now. And we don't get a response. And the issue, again, I made another error over here. It shouldn't be a % sign right over here. The % sign should be over here. All right, so let's fix that. Hit send. And we get a different error, so this is a good sign. Let's click on Poll Now. And here we go. So we get an HTTP ping and a DNS ping. And if you look over here, it's from the IP address of the application. But that's not really the interesting part. The interesting part over here is that the application outputs the error of the XML parser. So what we're going to do is, instead of trying to exfiltrate data to our attacker-controlled server, we're going to get the application to exfiltrate the data for us and present it in the form of an error. And to do that, we need to host our malicious DTD on our attacker-controlled server, which is the server that is provided for us in the application. So I'm going to close Burp Collaborator. We no longer need it. We proved that the application is vulnerable to a blind XXE. And what we're going to do is we're going to go to exploit server right over here and add our malicious DTD on the exploit server and then call it from the application. So let's make a new line over here and say exfiltration of data. So our malicious DTD will be really similar to the previous one. First, we're going to define an external entity called file, which calls the file that we want to exfiltrate. So we'll say file, and the file we want to exfiltrate is the XXE passwd file. So we'll add that right over here. And then we're going to create an entity within an entity. And if none of this makes sense, I would urge you to watch the theory video for XXE injection to understand the technical details behind every attack that we perform. Okay, so this is an entity within an entity, so we'll define another entity over here. And again, over here, you can't use the % sign. You need to use the hex version of the % sign, so that would be hash x25. And then we'll call this entity exfil. And what this will do is it'll essentially try to access a file just like this entity over here, but it'll access a non-existent file, which will cause the application to throw an error, which will be displayed to us in the application as we saw with the previous request. So to do that, again, we're just accessing a file that doesn't exist. So let's say it's called invalid or non-existent or whatever you want. And then we're also trying to access the content of the file parameter entity. So I'll explain that in a bit. Let's close this off. And here we go. So essentially what this will do is the file parameter entity will get evaluated to the content of the XXE passwd file. And then when the exfil parameter entity gets evaluated, it'll try to retrieve the path invalid / the content of the XXE passwd file, which is of course an invalid path. It'll output an error saying this path, which is invalid / the content of the XXE passwd file, does not exist. And since the application over here, we saw outputs the content of the error, it should output that error saying that the path invalid / the content of the XE path.wd file does not exist. And so it'll output essentially the content of the path.wd file for us. And that's essentially it. So we need to call our parameter entities, so eval and exfil. And let's not forget our semicolons. All right, this looks good. Hopefully I don't have any errors in this. Let's copy this, put it in here, click on store. And then all we have to do is go back to burp and then call our malicious DTD. Now, instead of burp collaborator, our malicious DTD is hosted on this server over here. So we're just going to copy this and paste it in here. And that is it. Hit send. And it did not work. We definitely have an error in the application because you could see over here it says decimal representation must immediately follow the AND hash in the character reference. So we have an issue over here, and that's because I made this capital, I believe, instead of lowercase. So let's fix that in here because the link to this document is available in the description. Let's store it. Go back, hit send. And here we go. You can see it says, congratulations, you solved the lab. And if we look at the error, what it did is, again, it tried to access the file path invalid. So /invalid / the value of the file parameter entity. But the value of the file parameter entity is our path.wd file. And so it's saying this path over here, this entire path does not exist. So we're really just triggering an XML parsing error where the error message contains the sensitive data that we want to retrieve in the application. All right, so we successfully completed the exercise by exploiting the vulnerability using the attacker-controlled server that is provided for us in the Web Security Academy. In the next lab, we'll look at another case of an XXE injection vulnerability.